So once again, good afternoon. So let's start with the second session. In this session, we'll discuss 20 questions. All right. Question number 19 till question number, I can say, what, till 38 here. All right. So 19 to 38. So a total of 20 questions. So time limit, I'm going to give you 50 minutes. Okay, 50. So time limit is 50 minutes, so that you should spend enough time on each and every question. That is very important. Okay, that you should try to solve each and every question. Okay, whether you get it right or wrong, that's immaterial, but you should try at least every question. All right, and those who are using mobile phone, it's advisable to switch to the laptop, so that for the live sessions you can switch to the laptop so that you can navigate through all the questions. All right, like someone with Pratisha, Devashish, Akash, these three people are using mobile phone, I can see. So Subhashish also, yes. So right now the time is 1:50. So 1:50 plus 50, that is till 2:40. So you have got the time till 2:40. So please try to solve all the questions till 2:40. And at 2:40 I'll start with the discussion. Okay, time up. So can we start with the discussion? Please tell me. Can we start with the discussion now? Am I audible to all of you? All right. So let's start. Guys need 5 more minutes. Please tell me, or should we start? Aditi, Akash, okay. 5 minutes. Okay, you guys need five. Last 5 minutes. So last 5 minutes. All right. Last 5 minutes. Please try. All right. So can I start with the discussion now? Please tell me. So what is the answer for question number 19? Please tell me, all of you. What is the answer for 19? That is option C. So this was easy. 10 points are marked on one straight line. So there are 10 points which are marked on one straight line. Okay. And 11 points are marked on another straight line, like this one. And triangle. So to draw one triangle, we need 2 points from the top line and 1 point from the bottom line. I'll get one triangle. Or select any 2 points from the bottom line and 1 point from the top one. I'll get another triangle. So it is 10 out of 10 points. 2 points from the first line can be selected in 10C 2 ways. And out of 11 point, one of the point can be selected in 11C 1 ways, or plus 2 points out of 11, 11C 2, and 1 point out of 10, 10C 1. So that is 10C 2. What is the value of 10C 2? That is equal to 45. Isn't it? 45 into 11 plus, what is 11C 2? 11C 2 is 11 into 10 by 2. That is 55. 55 into 10. And if it is 55 into 10, just solve this and you'll get the answer. So what is the answer coming out to be? Can anyone tell me? This is 55 into 10. 1045. So the answer is nothing but 1045. And this is the answer. So let me mark the answer quickly. Just a minute, guys. Just wait for a second. Okay. So I can say the answer is option C. All right, let's move to the next question. What is the answer for question number 20? A very, very interesting question. We have done this in the class also. Option E, 3. All right, that's right. I think the answer is option number A. I'll discuss it again. Let's see. For a scholarship, at most n candidate out of 2n plus 1 can be selected. And if the number of different ways of selection of at least one candidate is 63, find the number of candidates that can be selected for one. So number of candidates, total number of candidates is an odd number. That is 2n plus 1 is an odd number. So if you observe here, like if I say odd number, okay, if the number of candidates is, let's say 3, so I'll say that is 3C0 plus 3C1 plus 3C2 and plus 3C3. This expression is always equal to 2 raised to power 3. And the sum of the first two terms, it is always going to be equal to the sum of the last two terms, which means the sum of the first two terms is 2 raised to power 3 by 2, which is 2 square. And the sum of the second last two terms, that is also 2 raised to power 3 by 2, which is 2 square. Okay. Now, similarly, if there are 5 terms, like if I say that is 5C0 plus 5C1 plus 5C2, whenever n is odd, so I can say 5C2 plus 5C3 plus 5C4 plus 5C5. And this is always equal to 2 raised to power 5. And the number of terms are even if 2n plus 1 is odd. In this case, the sum of the first 3 terms is always equal to sum of last 3 terms. So there are 6 terms. Okay. So the sum of first 3 terms, that is going to be 2 raised to power 5 by 2. I'll divide the total sum in 2 equal parts. Okay. That is equal to 2 raised to power 4. And this will be also 2 raised to power 5 by 2, which is 2 raised to 4. And so on. In this case, the total number of candidates is 2n plus 1. So I can say out of 2n plus 1, if I'm selecting 0 candidates, so 0 plus 2n plus 1, C1 plus so on till I can say that is 2n plus 1, Cn plus 2n plus 1, Cn plus 1 and so on till 2n plus 1, C 2n plus 1. And this expression, it is always equal to 2 raised to power n. Now, from NC0 to here till n, alright, not this, till this one. Okay. Now, can I say this particular sum is this here, which I have highlighted right now? How many terms are there? From 0 to n, you can say C0, C1 till Cn. 0 to n, the total number of terms is nothing but that is equal to n plus 1. Okay. So here this total sum, it is equal to nothing but I can say these are n plus 1 terms. Okay. And n plus 1 to 2n plus 1, that is also n plus 1 terms. And the total number of terms is 2n plus 2. If it is 3, then there are 4 terms. For 4, there are, sorry, if it is 5, then we are getting 6 terms. If it is 2n plus 1, I'll getting 2n plus 2 terms. And these are the 2n plus 2 terms. And again, the sum will be what? The sum of this yellow portion, which I have highlighted, the total sum, it will be equal to 2 raised to power n by 2, which is equal to 2 raised to power n minus 1. Any doubts to anyone till this step? Please tell me. No? All right. Now, what does the question say? The question says, if the number of different ways in which a selection of at least one candidate and the maximum n candidates, so minimum 1 and the maximum n, it is equal to 63. Okay. So, which means, do I need to include this 2n plus 1 C0? Remember, maximum it is 2n plus 1 Cn. Do I need to include 2n plus 1 C0? No, I do not need to include this term. So if I include this, so can I say the sum of the remaining C1 to Cn, 2n plus 1 C1 to 2n plus Cn, this sum is given as nothing but 63. And 2n plus 1 C0, this is equal to what? 1. Devashish, it says, for a scholarship, I need to select maximum n and the minimum 1. So maximum is n, that is 2n plus 1 Cn. And the minimum 1, so 2n plus 1 C1 to Cn. So basically, we need to find out the sum of the numbers. Okay, let me highlight that. We need to find out the sum of the numbers starting from here to here. Okay, I need to find out this sum here. This sum, it is given as nothing but this particular sum is equal to 63, which I have highlighted by blue color. So let me write down this sum, it is equal to 63. And 2n plus 1 C0, that is equal to 1. And 1 plus 63 is 64. So which means 2 raised to power n minus 1, it is equal to 64. And 64 is equal to 2 raised to power 6. Okay. So 2 raised to power 5 is 32, 2 raised to power 6 is 64. So from here I can say n minus 1 or somewhere. The question is maximum number of candidates that can be selected is, for the scholarship is, okay, Priyank is saying sum of all terms will be, yes, yes. ये गलत लिख दिया. That's, let me make a correction. This here it has to be, just a minute. Let me take a eraser. Yes. This is, yeah. This is what? 2 raised to power n minus 1. So this is 2 raised to power n plus 1. Okay, for 5 it is 2 raised to power 5, for 3 it is 3, so for 2n plus 1. So this term, this entire sum, that is basically 2 raised to power 2n plus 1 by 2. Okay, and this value, it is equal to nothing but 64. So from here I get that is 2 raised to power 2n plus 1. Cross multiply, I get that is equal to 2 raised to power 7. So from this I can say 2n plus 1, it is equal to 7. Okay, 2n plus 1, it is equal to 7. So n is equal to 3, and this is the answer. So any doubts to anyone now? Clear? Devashish and everyone? So can we move to the next slide? And next question. All right. Now, next part here. Now, what is the answer of this question? Question number 21. The correct answer is option A. That is equal to 6. Okay, let's see here. It says one red flag. So there is one red flag. There are 3 white flags and 2 blue flags are arranged in a line such that no 2 adjacent flags are of the same color. Okay, so no 2 adjacent flags are of the same color. So we know the maximum number is of white. So in between these two, there must be something, yes or no? In between these 3 white, I need to put at something at between these 2 places. And the flags at the 2 ends are of the different colors. So can you say there will be 2 possibilities? This combination, or I can say W dash W dash W. Okay, then only the flags will be of different color. Okay, so there are 3 different white colors, I can say, and I can't put the remaining 3 colors, that is blue and white, only between these 2. In that case, the 2 white will become same, which is not possible. Sorry, the first and last will become same. And here also. And at these 3 places, I need to put 2 blue and red. Okay, so at these 3 places, I need to put 2 blue and red. So these are 3 places, and at these 3 places, I need to arrange 2 blue and 1 red. So they can arrange themselves in how many ways? Factorial 3 by factorial 2. So factorial 3 by factorial 2, that will be comes out to be 6 here. So sorry, factorial 3 by factorial 2 is 3. Similarly, there is another 3 cases here also. I can say these 3 places, it can be arranged in by blue, blue and red. So factorial 3 by factorial 2, again 3. So the answer is 3 plus 3, which is equal to 6. And this is the answer. Any doubts to anyone now? So should I move to the next question? Aditi, Akash and everyone? All right. Yes. What is the answer for this particular question? An interesting one. Nikita is saying option C, Damini is saying C. Okay, most of you have got it right. Great. The correct answer is definitely option number C, 3402. Okay, so let me discuss it quickly. Sam has forgotten his friend's 7-digit telephone. So there are a total of 7-digit number. 1, 2, 3, 4, 5, 6, 7. Okay. He remembers the following. The first 3 digits are either 635 or 674. So the first 3 places can be arranged in 2 different ways. Okay. The number is odd. So the number is odd. So the last place I can put the number either 1 or 3 or 5 or 7 or 9. Okay. And the number 9 appears 1. So I am using the number 9. So number 9 plays an important role here. Okay. So the number 9 will play an important role here. So you need to be very, very careful. Okay. If a Sam were to use a trial and error process to reach his friend, what is the minimum number of trials he has to make before he can be certain to succeed? Before he can be certain to succeed. So now what I'll do, I'll make 2 different cases. Okay. The first case if the last digit is 9, and the second case if last digit is not 9. Okay. So I'll say last digit is 9. Okay. So last digit is nothing but that is 9. Okay. So the last digit is 9. Now, if the last digit is 9, so remember first 3 places and then 4, 5, 6, 7. Last place is 9. So there is exactly one way to fill the last place. The first 3 places, it can be filled in a total of how many ways? That is how much? I can say 2 ways. Okay. Now the remaining 3 places. Now at these 3 places, can I say I can put any of the number from 0 to 8? Because remember the number 9 appears once. The number 9 appears once. Except the number 9, the rest of the number can appear any number of times. Okay, so 0 to 8. 0 to 8, how many numbers are there? 9 numbers. So I can put any number from 0 to 8 at this place. 0 to 8 at this place. 0 to 8 at this place. So 9 into 9 into 9 and into 1 into 2. So how many cases? 9 threes are 9 cube, it is equal to 729. So this is 729 into 2. Any doubts to anyone now in the first part? No. Second case, if the last digit is not 9. Okay, last digit is not 9. So 1, 2, 3, 4, 5, 6, 7, 8, 7 digit number I need to form here. Okay, and I'm assuming the last digit is not 9. So the first 3 places, it can be filled in a total of 2 ways. Last place, it can be either 1 or 3 or 7 or 5. There are a total of 4 ways. Now out of these 3 places, at one of the places I'm going to use 9. So the 9 can come at any of these 3 places in 3 different ways. And the remaining 2 places, I can put any numbers from 0 to 8. So 3 into 8 into 8. Is this clear to all of you? Last part, I'm going to repeat. Last place has got 4 choices. First 3 digit has got 2 choices. Now there are 3 places. Out of these 3 places, at one place I need to put 9. So there are 3 choices for 9. 9 can go to either be 4th digit, 5th digit or 6th digit. So 3 choices for 9. And in the remaining 2 places, I can use any number from 0 to 8. So 8 into 8. Alright. And this will be, comes out to be, this is 4 into 2 is 8. 8 cube is 512. So, sorry, this is 512 into 3. And add these 2 values. And if you add these 2, so I think the answer will be, comes out to be, how much? That is 3402. And that will be the answer. Any doubts to anyone? Please respond. Okay, sorry, yes, 0 to 8 are 9 digits. So I have, yes, that's right. 0 to 8 are 9 digits. So I have written 8, 0 to 8 are 9 digits. So you can write down 9 into 9. Perfect. Okay, so 9 into 9 into 3 into 6. Sorry, 9 into 9 into 3 into 8. So this will be, add these 2 numbers, the final answer will be 3402. Is that clear? Please tell me yes or no. Let's move to the next question. 23. Another very interesting question. What is the answer for question number 23? Tell me. Option D. Okay, all of you are saying option D. Let's see. It says there are, I think the answer is option A. Damini has got it right. All those who have got the wrong answers, all of you have got option D. So it means, let's see what is the error here. There are 3 cities A, B, and C. So there are 3 cities A, B, and C. Each of these cities is connected with other 2 cities by at least one direct road. So city A is connected by city B. I can say city A is also directly connected with C. City B is also connected with directly with city C. Okay. Now, if a traveler wants to go from one city to another city, she can do either by traversing a road connecting to the 2 cities directly or traversing 2 roads. The first connecting the origin to the 3rd city and the second connecting the 3rd city to the destination. In all, there are 33 routes from A to B, including those via C. Similarly, there are 23 routes from B to C. Okay. Now, let's say here, let's say A to B, there are X route. and A to C there are y root, and B to C there are z root. So the first thing, A to B to C. It says in all there are 33 roots from A to B. All right. So there are total of 33 roots from A to B. So how can I reach from A to B? Either there will be a direct route from A to B, or I'll move from A to C to B. And these total is 33. So A to B there is x, and A to C is y, and C to B is nothing but z. So x plus yz, it is equal to 33. That is one of the equations. Okay. 23 routes from B to C. So either I can travel directly from B to C, or I'll move from, first of all, B to A and then A to C. So B to C there are z root, okay, and C to A, or second way, B to A is x, and A to C, it is nothing but that is y. So z plus xy, and this is equal to 23. Now add these two equations. If I add these two equations, what will I get? That x plus yz plus z plus xy, it is equal to nothing but that is 33 plus 23. Now 33 plus 23. Now here, if you look at here, add these two terms. So I'll say x plus z. Okay. Add these two terms. Y is common, so plus y into x plus z. So let me write down y into x plus z. So y into x plus z, and that is equal to 33 plus 23. What is this 33 plus 23? 56. Am I right? Yes, that is 56. So from here, you can say you'll be getting that x plus z is common. So x plus z into 1 plus y. It is equal to 56. All right. This expression is equal to 56. So the question is basically, now remember the number of roots, it has to be integer. So the question is basically in how many ways 56 can be written as a sum of two integers, sorry, product of two integers. Okay. So what are the different possibilities here? 56. Okay. 7 is one of the factor. Yes or no? 7 into 8. Okay. So if I say, let's say this is equal to 7 and this is equal to 8. If I take into this form, 8 into 7 here. So if y is equal to 7, can you guys tell me how many roads are directly from A to C? So A to C, if 1 plus y is equal to 7, in that case y is equal to 6. Any other possible combinations, please tell me. I need to select the value in such a way that here. (14 into 4). All right. Whether 14 into 4 will satisfy, that is another thing we all need to cross check. Whether 14 into 4 will satisfy. Just check and tell me, all of you. The question is how many roads are there direct from A to C directly. Yes. Now just here. The question is how many roads are there from A to C directly. Let me highlight the question here. Direct road from A to C. Direct road from A to C is nothing but that is y, and this is what I need to calculate here. Okay. Or another thing is that at least one direct road is there. So let's see what all solutions. In the first case, if I'm written that is 8 into 7. So in the first case, I'll get here like y is equal to 6. Y is equal to 6 and x plus z, it is equal to nothing but that is equal to 8. Okay. And if I'm getting x plus z is equal to 8 here. So it will satisfy all the equations also. Like when I say 33. Okay. 33 is equal to x plus yz. So x plus 6y. And the 23, it is equal to nothing. That is equal to, if I put y equal to 6. Sorry, this is 6z over, no? Yes. X plus yz. So y is 6, so z is here. I can say x plus 6z. And the second here equation I'll get that is equal to z plus xy, that is equal to 6x. Alright. So in that case, can we identify what are the values of x and z by solving these two equations? All of them has to be integer. That is very, very important, that all the value x, y, and z, they need to be an integer only. Okay, they need to be an integer only. So I think in this case you will get an integer. This is, if I add these two, तो इससे तो कुछ मिलेगा नहीं. I'll get only x plus z is equal to 8. But however, if I take a difference of these two equations, what is 33 minus 23? That is equal to 10. And if I take a 10, if I take a difference to 6z minus z, that is 5 into z minus this. 6z minus z, it is 5z, and z minus x. So z minus x, it is equal to 2. So z minus x is equal to 2 and z plus x is equal to 8. If I solve this, so 8 plus 2, 10, half of 10 is 5. So I'll get z is equal to 5 and x is equal to how much? 3. So this will give me an integral solution. Other values will not give me, I think, probably the integral solution. So that's the only solution. Is that clear? Please respond. Or do I need to solve the second case also by assuming that is something else? How did you all have got 10? A lot of you guys have got 10. Kaise aaya tha 10? Can you guys tell me what mistake you all have committed to get the answer as 10? If y is equal to 10, in that case 1 plus y is equal to 11, no, which is not possible. So can I move to the next slide? Please tell me now if this part is clear. So the answer is 6. Other values will not satisfy. Now, question number 24, another very, very interesting question based on pigeonhole principle. What is the answer? Tell me. The correct answer is option C, Hema. We have done in the class also exactly same question. It says of 128 boxes of oranges, each box contains at least 120 oranges. Okay. So the number of oranges in each of the box can be 120. So minimum I can say there is 120 oranges. Yes or no? So 120 oranges, minimum, that is 120 oranges. I can say number of oranges. It is less than equal to 144 and greater than equal to 20. So what are the possible number of oranges? The possible number of oranges is 120, 121, 122 and so on till 144. There are 25 possibilities, yes or no? Okay. The question is the number of boxes containing the same number of oranges. So I'll say in 120 oranges, 121 oranges, 122 oranges, 123 oranges, 124 oranges, and so on till maximum 144 oranges. And I need to minimize the boxes which contain the same number of oranges. So what I should try? I should try that in all the boxes the number of oranges should be different. So I'll say in the box number B1 I'll put 120 oranges. In the box number B2 I'll put 121. In box B3 I'll put 122. In box B4 I'll put 123 and so on. And in box number 25 I'll put 144. But we have got 128 boxes. So 25 different variety quantity of oranges in 25 different boxes. Now box number 26, one of the thing is going to repeat it. So let's say in box 6, I put again 120. In box 7, 121. Box 8, 122. Box 9, 123. And so on till box number 50. Alright. So at the max in 25 different box, I can put different number of oranges. So after that it will start repeating. Then box number 51, box number 52, and so on till I can say box number 75. And we have got 125 boxes. So divide 125 by 25. I'll get 5. So can I say I'll get 5 such cycles? Yes or no? I'll get 5 such cycles. And in these 5 cycles, 125 boxes will be covered. Still 3 boxes are remaining. So I'll start in the 6th row. So I'll say, let's say box number 126, box number 127, box number 128. So you can observe minimum in 6 boxes, the number of oranges is always going to be same. So minimum number of boxes in which the number of orange will be same, that is definitely 6. So the answer is 6. Is that part clear to all of you? Now, this is known as pigeonhole principle. There are 100, okay. The question is, out of 128 boxes of orange, each box contains minimum 120 and the maximum 144. The number of boxes containing the same number of oranges at least. Okay. So the number of oranges, I should try that in each of the boxes, the number of oranges is different. But the different possible quantities are 25. In one box, I can put 120 or 120 or at the max 140. So if I say, if I have got 25 boxes only, if I've got 25 boxes, so can you say it's possible that in all those 25 boxes, the number of oranges are different? But if the number of boxes is 26, okay, then in 2 of the boxes, the quantity will be same. Even if there are 27, then 2 of the boxes, the quantity is going to be same. If it is 28, then also I can say in 2 of the boxes, minimum 2 of the boxes, the quantity is same. So I can say if there are 50 boxes, okay, if there are 50 boxes, so in that case also I can say minimum 2 boxes will be there in which the quantity will be same. But if the number of boxes is 51, so in the 51st box, again the third row will start. So one of the quantity will again, in 3 of the boxes, the quantity will be same. So similarly, I'll divide 125 by 5, or I'll say 128 by 5. 128 by 5 is 5 point something, so the answer is 6. That's a simple, if your funda are clear of pigeonhole principle, then you can do it. Or just see, 25 into 5, there are 5 layers, 125 boxes. Now, box number 126, 127, 128, 6th row I have started, so you can see that there are minimum 6 boxes in which there is exactly same number of oranges. Clear now? Can we move to the next slide? Akash and everyone, Aditi, Ankur. Okay. Now, what is the answer for this question? Question number 25. The correct answer for this is option number B, which is 10. Again, whenever you see a complicated figure, now you can go for Pascals here. Tell me one thing. B, point B, if I'm starting from A, at point B, I can reach in how many ways? There is only one path from A to B. Yes or no? So I can write down 1. Point B, I'll reach in only one way. Now, point C, D. Remember, I am coming from A to D or from B to D. So B can be reached at one way. So again, this 1 and 1 from here. So 1 plus 1, that is equal to 2. So I can say at point D, I can reach in a total of 2 ways. Now, let's say talk about E. So E, I am reaching from D as well as B as well as from C. So C, we have no idea, so just wait. Now B to C. B to C one ways and D to C 2 ways. Because D I can reach in 2 ways and again 2 into 1, that is 2 ways. So B to C 1 ways, D to C 2 ways, and there is no other path which is coming towards C. So at point C I can reach in 1 plus 2, a total of 3 ways. So I can write down this is equal to 1 plus 2, which is equal to total of 3 ways. Now, at point E. Now, point E, there are 3 paths. So from point C, I can reach in 3 different ways. From point B, I can reach in 1 way. And from point D, I can reach in 2 ways. So 3 plus 1 plus 2. 3 plus 1 plus 2, I can say that is 6 ways. So at point B, I can reach in, that is 6 ways. And from point E to F, or from F. So at F, I am reaching from C. So from C to F 3, from B to F 1, and from E to F 6. So 3 plus 1, 4, 4 plus 6, that is equal to 10. So the answer is here 3 plus 1 plus 4. So you can say the answer is 10. So plus 6, which is 10. So the answer is option B. Any doubts to anyone now? No. So you can see that this approach is very simple approach and most of the time you'll get a correct answer. All right, let's move to the next one, 26. What is the answer for question number 26? Okay, some of you are saying B, some of you are saying C. The correct answer choice is actually C, not B. Let n be the number of different 5-digit number divisible by 4. Okay, no digit being repeated in the number. So 5-digit number divisible by 4. So what is the divisibility rule of 4? The last 2 digits should be divisible by 4. Okay, so the last 2 digits should be divisible by 4. So make the cases. I can say 12, then 16, yes or no? Alright. If I start with the digit 2, 24 only. If I start with the digit 3, so 32 and 36. Start in one particular order. If I start with the digit 4, then 42, no, 46 not possible. Then if I start with the digit 5, so 5 say 52 and then 56. And if I start with 6, then 64. Is there any other ways in which the last 2 digits can be selected? Please tell me. No. So what is the total? What is the total number of ways in which the last 2 digits can be selected? I can say, let me count 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 ways in which the last 2 places can be filled. So out of 6 of the digits, 2 of the digits has been used. Okay, out of 6 digits, 2 digits has been used. So we are left out with how many digits? We are left out with 4 digits. So this place have got 4 choices. This place has got 3 choices. And this place has got 2 choices, as repetitions are not allowed. So 4 into 3 into 2 into 8, which will be comes out to be how much? 192. So the answer is 192. Any doubts to anyone? Can I move to the next question? 27. A very, very interesting question, in fact. What is the answer? This is one of the easiest also. I think I remember the same question I was asked in 2015 also in my set. No? All right, let's see here. It says n1, n2, n3 till n10 are 10 numbers such that n1 is greater than 0. And the numbers are given in ascending order. How many triplets can be formed using these numbers such that in each triplet the first number is less than the second number and the second number is less than the third number? Okay, so there are 10 numbers. Out of 10 numbers, you can pick 3 numbers in how many ways? 10C2 ways. You pick any 3 numbers, there is only one possible arrangement. It says first number, if I pick, let's say, n1 and n5 and n7. So there is only one possible order. So if I pick out of these 10 numbers, I pick any number, the number of arrangement will be only 1. So the answer is simply 10C2 into 1. And what is 10C2? 10 into 9 by 2, which is equal to 45. Isn't it? 10C2 equal to 45. So this is the answer. Any doubts to anyone now? Please tell me. Sorry, 10C, no, it will be 10C3. 3 numbers. Yes, it is 10C3. Okay, 10C3. Okay. Not 10C2. I am selecting 3 numbers. So if I select any 3 numbers, the answer is 120. That's the correct answer. The correct answer is 120. Clear now? It says in how many ways triplets can be formed such that first number is less than second, second number is less than third. So if I pick 10 numbers, okay, you pick any 10 numbers, there is only one possible arrangement. First number, second number, third number. That's it. So the answer is simply 10C3. Is that clear now, Avinash and everyone? Aditi, Akash, okay, great. So the answer is 10C3, which is 120. 28. Yes. What is the answer for this question? Question number 28. how many numbers between 0 and 1 million can be formed? The answer is option number C, 728. That's right. The answer is option C, 728. Now, 0 and 1 million. In 1 million, how many zeros are there? That is 10 raised to power 6. 1 million is equal to 10 raised to power 6. So 1, 2, 3, 4, 5, 6. So 10 raised to power 6 is a 7-digit number. So if I am talking about number between 0 and 1 million, so maximum there can be 6 digits, and I am allowed to use only these 3 digits, 0, 7, 8. Okay, so I can say the first place I can put either 0 or 7 or 8. At the second place also 3 possibilities, 0, 7 or 8. Third place also either 0, 7 or 8. So each of the place has got exactly 3 possibilities here. So what is the answer? That is equal to 3 raised to power 6. But out of these 3 raised to power 6, there will be one case in which, when I'm saying that each of the places got 3 possibilities, so there will be one case in which at all the 6 places I put 0. But the question is saying how many numbers between 0 and 1 million. So I do not need to include this. So the answer is what? That is 3 raised to power 6 minus 1, which is equal to 7. Any doubts to anyone now? Okay, please respond. Now, some of you might have done in this way, that how many single digit number, 2 digit, 3 digit, 4 digit. How many of you have done in that way? Counting first single digit, then 2 digit, then 3 digit, then 4 digit. How many of you have done in this way? Anyone? Yes. I told you in the class also now that between us, so we can do it directly. You have got the same answer, 728. Because what will happen if I include 0? Like, since we are forming a 6-digit number. So when I'm saying, let's say that 0 comes at the 5 places, if the repetitions are allowed. 0 comes at the first 5 position, 0 is there. And at the last 2 position, 7 or 8 is there. It means in this method, all single digit number are already counted. Since 0 is also allowed as the leading digit. So it might be possible the first 4 places I have got 0, and the last 2 places, let's say 78 or maybe 77 or maybe 88. So this method in 3 raised to power 6, everything is included, whether it's a single digit or 2 digit or 3 digit or 4 digit. Okay. If the leading digit 0, then I'll get a 5-digit number. If the first 2 digit is 0, I'll automatically get 4 digits. If the first 3 digit is 0, I'll automatically get 3 digits. So there is no need for making the separate cases. You can just do like this and subtract 1. Any doubt? Can I move to the next question now? Okay. Now, another very, very interesting question. What is the answer for question number 29? The correct answer is option number D. In how many ways choose a black and white square on a chessboard such that the two are not they did not belong to same row and same column? The correct answer for this is, can anyone tell me what is the correct answer? No. The correct answer is 768. In a standard chessboard, how many squares are there? Tell me. In a standard chessboard, how many squares are there? How many squares are there? 64. Now, so if I say, let's say this is black, then white, then black, then white, then black, then white, and then black and white. Yes or no? 8 cells are there. Then it will be white, black, okay, white, black, white, black, white, black. Okay, it will be like this. All right. I'm just write down quickly. Instead of making the table, I'll just write down in this way. So black, white, black, white, black, white, black, white. Okay. Then white, black, white, black, white, black, white, black. Let me write down quickly. I was expecting that all of you will get the correct answer of this. as we have spent around 2 hours on chessboard all in the class. Eight हो गए यहाँ पे. That's right. White, black, white, black, white, black. Now I need to select two squares. Take a one black and one white such that they did not belong to same row and same column. Now the first square, it can be selected in how many ways? 64 ways. Okay. I can say the first square, it can be selected in a total of 64 ways. But it can be either white or black. So let's make two cases here instead of doing in this way. I'll say out of this 64, there are 32 black and 32 white. All right. There are 32 black and 32 white. So there are 32 black and 32 white. Now let's say I selected first black. So out of the 32 black, I can select any one black in how many ways? That is 32 ways. Yes or no? Into. Once I select any particular black cells, let me highlight that. Let's say if I select this as a black. Okay. Then I can't select the. Okay. Then black, one black and white. Okay. So I need to select a white which did not belong to the same row and same column. Okay. Which did not belong to same row and same column. So can you tell me how many white I can't select? You can say 1, 2, 3, and 4. These 4 and these 4. So for white, how many possibilities are there? So for white, how many possibilities are there? 32 minus 8, which is 24. Yes or no? 32 minus 8, which is equal to 24. So I say 32 into 24. And 32 into 24, that is equal to 768. And this is the answer. So any doubts to anyone now? Please tell me. So can I move to the next question? All right, let's move ahead. 30 and 31. What is the answer for question number 30? A set of two questions. Yes, that's right. 30 is nothing but that is equal to the option number C. Perfect. It says, easy tha ye. There are 11 alphabets that are called symmetrical. So there are symmetrical, there are 11. Okay. And asymmetrical, I can say there are 25. Not 25, but how much? 15. Total 26 letters are there. So asymmetrical is 15. Okay. So symmetrical 11, asymmetrical is 15. How many 4-letter passwords can be formed by using symmetrical letters only? So 4-letter passwords can be formed by using symmetrical. So it is simply 11 into 10 into 9 into 8. So now, as it's a multiple of 10, so answer should end with a 0. So I can easily reject two of the options. Always pay attention to the options also. It's not necessary to calculate, but since one of the option is none of these, so it means I might need to calculate it. So anyway, if you solve this, you'll get it as 7920. Can I move to the next slide? Please tell me. So this was a very simple one. What is the answer for question number 31? What is the answer for question number 31? A. Now, it says how many 3-letter words can be formed such that at least one symmetrical letter is used. So there are total of how many symmetrical letters are there? That is 11. And asymmetrical letter, it is equal to 15. Okay. We need at least one symmetrical. Okay. First of all, 3-letter words. So how many 3-letter words can be formed total? Total 3-letter word is nothing but that is 26 into 26 into 26. Now, that is going to be equal to 26 cube. Okay. Total. And how many letters are there? This is the total. I need at least one symmetrical. So how many letters you can form in which all the letters are asymmetrical? All the 3 letters are asymmetrical. So this will be equal to nothing but that is 15 into 15 into 15. So that is equal to 15 cube. So if I need at least one symmetrical, so that will be equal to total, which is 26 cube, minus the case in which none of the letter is symmetrical. Because at least one is always equal to total minus none. We know that. At least one is always total minus none. So 26 cube minus 15 cube. Solve this, you'll get the answer as 14201. Even if you do not know, calculate the answer, what is the last digit? If you pay attention, 26 cube last digit is 6. 15 cube the last digit is 5. So 6 minus 5, 1. So for the answer, the last digit has to be 1. So the answer can't be A, B, and C. And you can mark the answer as option number D. Use this funda of last digit to get the answers with the help of options instead of doing the calculations. Is that clear to all of you? The correct answer is 14201. Any doubts to anyone now? Okay, Mugda is saying something. Let me see. Can we make 3 cases? Yes, you can make 3 cases and then you can add 1. Yes, definitely. If I'm using exactly 1 symmetrical, or if I'm using 2 symmetrical, or if I'm using exactly 3 symmetrical. Okay, Mugda, you'll get the same answer. All right. Now, question number 31 we have done. 32. What is the answer of 32? Yes, Rohan has got it right. The answer is option C, which is 240. Let's see how. How many 3-digit positive integers with digit x, y, z at the 100, tens, and the units place, such that x is less than y. So x is less than y, and y is greater than z, and x is not equal to 0. All right. So what I can say, let's say if I say here, can y be equal to 1? Tell me, can y be equal to 1? No. In that case, x equal to 0, which is not possible. So just negate that. Y can't be equal to 1. So let's say if I say y is equal to 2. If y equal to 2, so x has got how many possibilities? X can be only 1, but z can be what? Z has to be less than 1. So z can be either 0 or 1. So can we say there are 1 into 2 ways? If y is equal to 3, so x can be either 1 or 2. Leading digit can't be 0. And z can be either 0, 1 or 2. That is equal to nothing but 2 into 3 ways. Okay. If y is equal to 4, then x can be either 1 or 2 or 3. And z can be either 0 or 1 or 2 or 3. So that is equal to 3 into 4. And so on. Maximum value of y is 9. When y is 9, x can take anything from 1 to 8. Okay. And y can take any values, sorry, z can take any values from 0 to 8. So I'll get how much? 8 into 9. So what is the answer? It is 1 into 2 plus 2 into 3 plus 3 into 4. Okay. Plus 4 into 5 plus 5 into 6 plus 6 into 7 plus 7 into 8 plus 8 into 9. So find the sum of this series and you'll get the answer. The sum of this series is 240. Is that part clear to all of you? Okay, even there is a shortcut for solving this series, which I have discussed in sequence and series topic. What is that shortcut? I can solve it in one way. There is a pattern, na? So I'll say 1 into 2 minus 8 into 9. Here write down 1 0 and here write down 1 10. And into minus 1 by how much? That is 6. So this will be 8 into 9 into 10. What is 8 into 9 into 10? 720 na, and 720 by 6. 720 by 6. I think 6 नहीं होगा, 3 होगा. This is not 6. Number of terms are 3 into common fraction. So by using that particular shortcut, I'll get the answer minus 1 by 3. That is equal to 240. So how many of you have remembered this shortcut? This is a shortcut which I have discussed in sequence and series. Those who have not completed sequence and series, do not worry. In the sequence series topic, I'll discuss how to solve such type of series. Otherwise, it's not a very large number. You just need to add 10 numbers, you'll get the answer as 240. Can I move to the next slide now? Please tell me. 33. What is the answer? Option B. I think this question is repeated. Yes or no? This question was asked in CAT 93 or 94, I do not remember. It's same question like this. In the first session, we have discussed this question. So can I move to the next question now? So at times in the CAT, some of the questions repeat also. 34, yes, that's interesting. What is the answer for 34? The answer is option B, 10 to 66. Let's see how. It says a graph may be defined as a set of points connected by lines called the edges. Every edges connect a pair of points. For example, triangle. So if I draw a triangle like this. So you can say a triangle is a graph with 3 edges, 3 points. So there are 3 points A, B, C, and there are edges means basically sides. So you can say there are 3 sides. Okay. So 3 edges and 3 points. So that's a triangle. The degree of a point is the number of edges connected to it. For example, a triangle is a graph with 3 points of degree 2 each. Okay, like point B, it is connected with these 2 points. So the degree of point B is 2. Okay. So the question is here, consider a graph with 12 points. It is possible to reach any points from any other points through a sequence of edges. The number of edges in the graph. So if there are 12 points, what is the minimum number of sides and what is the maximum number of sides that I need to find out? Now there are 12 points. So let's say there is a point here, and I'll say 12 points. Let's say this is point A. So I can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So these are remaining 12 points. So the minimum number of edges will be nothing but that will be 11. Okay, because the question says it is possible to reach from any point to from any other point through a sequence of edges. So the minimum number of edges, it will be nothing but that is 11. Okay, so if there are 12 points and from point A, if I connect the point A from the remaining 12 points, from the remaining 11 points, so I'll get a minimum of 11 edges. Is that clear? Okay, so the answer is not option B. I think I marked it wrong. Answer is option A. All right. So the minimum number of points is 11. Is that clear? There are 12 points. There is 1 point here. Connect this 1 point with the remaining 11 points. Connect this 1 point with the remaining 11 points. So I'll get a minimum of nothing but how much? 11. Is that clear to all of you? Please tell me yes or no. All right. So there is 11. Now maximum. For maximum, I'll say out of 12 points. Out of 12 points, select any 2 points. You'll get one side by joining that 2 points. So 12C2, that is equal to 66. This is the maximum. Okay. So for maximum, out of 12 points, select any 2 points and join them together. So that is 66 edges will be there. And for minimum, I can say 11. So the correct answer is option number A, which is 11 to 66. So any doubts to anyone now in this question? All right, let's move to the next question quickly. 35 and 36. So 35, what is the answer for 35? That's right, answer is option D. So this was an easy one. A string of 3 letters is formed here. So 3 letters. First letter is vowel, so that is 5. The second letter is M, N or P. So let's say second letter is M. First letter has got 5 choices. If the second letter is M, then the third letter is any vowel which is different from the first letter. So can I say 4 ways? Like first place, I am using A, E, I, O, and U. So if I'm using the second letter is M, so the next place, it will be different from the first position. So there are 4 ways. So 5 into 4, that is 20. If the second letter is N, if the second letter is N, then the third letter is E or U. So third letter has got only 2 possibilities, E or U. And here first letter 5. So I can say that is 5 into 2, which is equal to 10. And if the second letter is P, the third letter is same as the first letter. So these are 5 and 5 possibilities. The same 5 letter will come here. Okay, so this is one, I'll say, one ways. Because if A, E, I, O, U, So the same letter will come here. So that is only one way. So that is 5 into 1, which is equal to 5. So the answer is 35. Any doubts to anyone? Please tell me. Why I have written 1? Because here, if it is A, E, I, O, and U. So the same letter will come. Now there is no other possibility. So that's why it is exactly one way. Like if I put here A, so this place will be also A. If it is E, then it is also E. I, then I. O means O, and U means U. So there are only 5 ways. Okay, let's move ahead. 36. What is the answer for 36? That's right. The correct answer is option C. It says how many strings of letter can be possibly formed using the above rule such that the third letter of the string is E. So third letter is nothing but that is E. That we know. So the third letter is E. That is already given to us. Now what are the possibilities for the second letter? If the second letter is M, just a minute. Okay. Yes. So if the second letter is M, okay. Now, and the condition is if the second is letter, then the third letter is any vowel which is different from the first letter. So the first letter, it has got 4 choices. Either it has A or I or O or E. It has to be different. So there are 4 possibilities. Last is E, if the second letter is N. If the second letter is N, then the third letter is E or E. So it is already E. And the first letter can be anything. There is no restriction. So it can be anything. A or E or I or O or E. There are 5 ways. If the third letter is P, sorry, second letter is P. If the second letter is P, then the third letter is same as the first letter. It means here also I need to put E. There is only 1. So answer is 4 plus 5 plus 1, which is equal to 10. Any doubts to anyone? Can I move to the next question? 37. Another very interesting question. What is the answer for 37? Answer is option number B, 90, which only one of you, Aditi, has got it right. The correct answer is 90. Let's see how. There are 12 towns grouped in 4 zones. So there are 4 zones. 1, second zone, third zone, and the fourth zone. And in each of the zone, there are 3 towns. Okay, in each zone, there are 3 towns. So let's say there are 3 towns, town A, B, and C. It is intended to connect the towns with a telephone line such that every 2 towns are connected with direct lines, 3 direct lines, if they belong to the same zone. So 3 direct lines if they belong to the same zone. Okay, so if there are 3 direct lines if they belong to the same zone. So I can say A is connected with B with 3 direct lines. B is connected with C with 3 direct lines. And A is also connected with C, 3 direct lines. So how many lines are there in one particular zone? How many lines are there within a one zone? 9 lines, yes or no? Okay, 3 plus 3 plus 3, that is total 9 lines. So there are 9 lines within each zone. So if I'm talking the zone, within a zone, a total of 9 into 4, there are 36 lines. Is that clear to all of you? Alright, now next point. And with only one direct line otherwise there is only direct line. In another town, there is another one line. So let me write it down here. Okay. So now again, just look at here. Let's say there is a town here, P and Q and R. Okay. So P, Q, R, then I need to count how many possible. And here again, there are 3. Let's say here I can say S, T, and U. And here I can say the lines, towns are M, N, and O. So if I start from any one point, let's say here. Okay. So if the point A, can you say point A, this town A, it is connected with line, this it will be connected with line N, line M and line O. Yes or no? This town A, it is connected with S as well as T as well as U also. Okay, for 3 towns. This A will be connected with P as well as Q as well as R also. Yes or no? So 3, 3, 3. There are 3 plus 3, 6 plus 3, 9. So each of the towns in the first zone, can you say there are 27 indirect lines? Yes or no? So there are 27 more here. Is that part clear to all of you? Just here, town A is connected with the second zone, third zone and fourth zone, and 3 towns are there. So 3 plus 3 plus 3, 9. Similarly, town B will be connected with 9 lines and town C will be also connected with 9 other lines in the different zones. So 9 3s are 27. Now, here the problem is here, if I am talking about PQR. So if you look at here, in this town, PQR, PQ and R is already connected with the first zone. So I need to connect now PQR with the zone 2, that is STU, and with the zone MNO. So how many extra lines I'll get? That is 9 into 2, which is equal to 18. I'll repeat. Just here, PQR, this is already connected with ABC. So do not count again. But if I make a new connection of town PQR with STU, so 9 lines, and town PQR with the MNO, again 9 lines. So 9 into 2, which is 18. So I'll get another 18 lines here. So I can write down, this is 9 into 2, which is equal to 18 lines. So 18 more lines are there. How are these 18 lines? Just here. This, and this. 3 lines from here. Okay. Town P. और फिर ये P को M, N and O also. So I'll get 18 lines. Is that clear to all of you? Now let's start with the third zone. So if the third zone, that is comprising of STU, it is already connected with town PQR, it is already connected with town ABC. So now I need to connect the town STU with town MNO. So how many new lines I'll get? Please tell me. Connect S with MNO, 3 points. T with MNO, 3. And U with MNO, that is 3. Or you can say simply 3 into 3, 9. Okay, 3 into 3, 9. So I will get another 9 lines here. Okay. And then after that, if I'm coming to this particular zone, the last zone, so it is already connected with ABC, it is already connected with PQR, it is already connected with STU. So the final answer, it is equal to 36 within a zone plus 27 plus 18 plus 9. Add all of them, and this value, it will come out to be, I think, 90, which is 90. And this is the answer. Any doubts to anyone now? Okay. Okay, Akash is saying, can we do like this 12 CT? Out of 12, we select any 2, so that is 12 C2, so 12 into 11 by 2. So 12 into 11 by 2, that is equal to 66. Yes or no? 66. And then in that case, you are adding, subtracting 12. Okay, if you subtract 12, so what is 66 minus 12? Those 12s which have been, to avoid the double counting. Yes, to avoid the double. 66 minus 12 क्या आएगा? Akash, you tell me. 54. And those 12 lines which you are subtracting, let me think. Out of 12, if we select any 2 towns, so 12 C2, I'll get all 1 direct lines. Yes, so that is 54. And those 12. And 36, how did you get 36? Yes. So yes, you can do that. Definitely there is nothing wrong. Within a zone, there are 36. I can say within a zone, there are 36. All right. Now plus total, I'll say that is again out of 12. If you select any 2 points, that is 12 C2, that will be equal to 12 C2 is 66. But there are some of the points which has been counted twice. Okay. So that part I need to subtract. And how many parts? That is 12. Within a zone, like if I'm talking about within a zone, so within a zone A to B, A to C, and B to C. So this 3 parts, it has been counted twice. So 3 parts in zone 1, 3 parts in zone PQR, 3 parts in zone STU, and 3 parts in MNO. So 3 4s are 12. Subtract those 12 also. All right. And you'll get the answer which is equal to 90. So that is also correct. Nothing wrong in that. Okay, perfect. Is that clear to all of you? The second other approach. So if you are doing it this way, you need to be clear that I need to subtract some cases to avoid double counting. And the last question, that is question number 38. Just a minute. Okay, this is the question which I have already discussed. The answer is what? Option A, which is 80. So there is no further discussion is needed for this question. This is again a repeat question. So I hope that all these questions are clear till 38. Any doubts to anyone? So how much break do you need? How much time for break? It's 3:55. Yes, Rohan, in the last question, tell me. Half an hour, ठीक है? In last question, no, repetition is not allowed. No? If I'm talking about the path, so definitely we can't repeat the same lines. We're talking about question number in 38. Okay, just a minute. Let me read the question here. Question number 38. What is the question? Just wait, guys. Question number 38. Okay, the answer is option C, 71. This is different actually. It seems to be exactly the same, but it is actually different. Just here how. It says an intelligence agency forms a code of 2 distinct digits. Yes. Here the repetitions are not allowed. So it is 2 distinct digits. That's right. So 2 distinct digits selected from 0, 1 to 9. Okay, so in any case, if it was not distinct, what was the answer? If it was not distinct, what was the answer? 80, we all know that. Do I need to write again? Nahin na? If it was not a distinct, if the repetitions are allowed, so okay, if the repetitions are allowed, the answer will be equal to 80. That we have done in which question number? I do not remember. In the morning, that was question number in the first session we have discussed. Let me write it down here also. Just give me 1 minute. Question number 7. Yes, that is question number 7, Aditi. That's right. So those who have not attended question number 7, they can refer to question number 7. If the repetitions are allowed 80. Now, how many codes are there for which there is no confusion? So I need to remove all the cases in which the repetition is occurring. So how many cases I need to remove? Tell me, all of you. Out of this 80, how many cases I need to subtract now? Can anyone tell me? And also it says that the first digit of the code is non-zero. The first digit of the code is also non-zero. Okay. And code of 2 distinct digits. So 2 distinct digits and the code is also non-zero. So out of those 80, I don't think 5 will be repeated. Which one will be repeated? 1, 1. Or we can do it in this way. Just do it here. We already know which can create confusion, the digits which can create confusion, that is 0, 1, 2, 3, sorry. Just a minute. The digits which can create a confusion is, that is 0, 1, 6, 8 and 9. Okay. Now if the repetitions are not allowed, and the leading digit can't be 0. Okay. So the first place, I need to form a 2-digit code now. Okay. So the first place, it has got how many choices? Please tell me. 9. Just wait. First place, it has got how many choices? 9. And the second place, it has got how many choices? Again 9. Okay. So 9 into 9, that is equal to 81. So there is a total of 81 cases will be there. Okay. Now, out of those 81 cases, I need to subtract all the cases here. Okay, in this 81 cases, there is no repetitions at all. All right, there is no repetitions at all. Now, how many of them can create a confusion? That I need to form out here. So if I see here, 2-digit letter, the first place, since the leading digit can't be equal to 0, so the first place it can be filled in how many ways? Tell me. That is 4 ways. The second place, again 4. Yes or no? Again 4. So 4 into 4, that will be equal to 16. Yes or no? But in 16, some of them will not create any confusion. Out of those 16, few of them will not create any confusion. Which all letters will not create any confusion? Please tell me. Which all letters will not create any confusion at all? That is ending with the 0. So just a minute. We have written in the previous question now. 69, yes. And 96, yes. So reverse will have 0 in front, which is not possible. Yes, reverse will have 0 in the front. So I can say 10. For example, the code 91 may appear as 6. So how many codes are there in which no such confusion? So that is equal to 10. Or I can say that is 20. Just write down all the numbers. So am I audible to all of you? वही मैं दिखाऊं. Which all digits are there? 69, 96, 10. You are saying 60, 80, and 90. Yes. These will not create any confusion at all. Okay, because the leading digit can't be 0. We know that. So these 6 will not create any confusion at all. So what should be the answer then? 81 minus 16 and plus this 6. So what is this value? 81 minus 16 plus 6. That is equal to 70. That's right. So the answer is, sorry, not 70, but 71. And that's the answer. So I hope that it is clear. It is not exactly the same. It was changed a little bit. Any doubts for anyone now? Please respond, all of you. Okay. So tell me how much time you need for the break, and then after that we'll start with the third session. Thirty minutes. Okay. Okay. All right. Just think in this way. Just wait. First of all, remember the leading digit can't be equal to 0, na? So in this case also, this time, why 169? Hima, we have discussed 69. Just write down on a piece of paper 69. Okay, and if you just write down on a piece of paper 69 and then reverse it, paper को fold करके वापस change करो, it will again look like at 69. Na? Just rotate it 180 degree. It will again looks like 69 only. Is that clear? So that why it won't make any difference. Is that clear? Okay. Or you could have done in this way. See, 60 how? Because 60 will not create any confusion. It is already given an intelligence agency forms a code of 2 distinct digits between 0 to 9. such that the first digit of the code is non-zero. So I already know that the first digit of the code is non-zero. So 60 and 06, these are two different things. Or what you could have done like this way, we know that the total 81 digits are there, isn't it? And the digits which can create a confusion, instead of including zero, okay, instead of including zero, write down which all digits can create a confusion. I can say that is either one can create a confusion, 6 can create a confusion, 8 can create a confusion, 9. Do not include 0 at all. Because since the leading digit can't be 0, so anything in which 0 is there, like 20, 30, 40, or 60, they will not create confusion. So form how many letters can be formed with the help of these two? I can say 4 into 3, which is equal to 12. And out of these 12, only 2 of them will not create any confusion, that is 69 and 96. So you can say in this way also, 81 minus 12 plus 2, which is equal to 71. So either you go in this way, or you can say, if I'm including 0, then you can say 81 minus 16 plus 6, which is equal to 71. So both the way you will get the same answer, that is option number C. Is that clear to all of you now? Anupam and everyone. All right, so right now time is 4:04. So let's start at 4:45. Is that okay? Let's complete at least permutation and combination today. Okay? So 4:45, 18 questions are there in the next session. Out of 18, 15 is from PNC and 3 is from the probability. So let's start at 4:45. We'll discuss after that, Nikita. All right? Okay, guys. See you at 4:45, all of you. Yes, you will be getting a new link. All right? Or you can join from this link also. It is just an extension of the same link.